Hello student, welcome to the lecture series of hypothesis testing. Till now in the hypothesis testing we have discussed about the null hypothesis and alternate hypothesis. We have also seen about the one-tailed and two-tailed test, and we have also seen what is the meaning of p-value and how do we use p-value in our hypothesis testing. Okay, and we have also seen one of the examples for hypothesis testing for mean, that is one-tailed test example. Okay, so now let us start discussion about the hypothesis testing for mean in a two-tailed test. This is the brief outline of the steps which you follow in our hypothesis testing. First of all, we write down the null hypothesis and alternate hypothesis. Okay, where null hypothesis is always the accepted fact about a certain parameter. Like for example, it's a fact that the mean length of the chocolate produced from a given factory is 10 centimeter. Okay, or mean rainfall in a particular region is 70 centimeter. Okay, while the alternate hypothesis is the researcher claim. So the researcher can provide the hypothesis about any parameter. Okay, let's say that h naught is mu naught, so ha can be greater than mu naught, or ha can be less than mu naught, or ha is not equal to mu naught. Okay, so depending upon the alternate hypothesis we select whether our test is one-tailed or two-tailed test. This we have also seen in our previous lectures. Okay, now after stating the hypothesis we will select the appropriate test statistic. Okay, test statistic would be z statistic, t statistic, or chi-square statistic. Okay, z statistic and t statistic are used for hypothesis testing of mean, whereas chi-square statistic are used for hypothesis testing of variance. Okay, so after selecting a proper test statistic we would calculate the p-value. Okay, and we would also select our level of significance, so that is denoted by alpha, that is level of significance. Okay, so if p is less than alpha then we would reject the null hypothesis, and if p is greater than alpha then we would accept the null hypothesis. So this is the brief outline of the steps. Now in case of hypothesis testing for mean, as you have already seen that we use either t statistic or z statistic. Okay, and if the population variance is unknown then we are going to use the t statistic, whereas if the population variance is known then we are going to use the z statistic. Okay, as given over here. Here s is nothing but the standard deviation of sample and sigma is the standard deviation of population. So depending upon whether we know the population variance we select either t statistic or z statistic. Okay, so now let us solve the given example. Here blood glucose levels for obese patients have a mean of 100 with a standard deviation of 15. A researcher thinks that a diet high in raw cornstarch will have a positive or negative effect on blood glucose levels. A sample of 30 patients who have tried the raw cornstarch diet have a mean glucose level of 105. Test the hypothesis that the raw cornstarch had an effect for confidence level of 95%. Let us first write down the data given in the question. Null hypothesis is what we call as the accepted fact. So here the accepted fact is the blood glucose level for obese patients. So it is being given that mean of blood glucose level is 100, and the alternate hypothesis, which is the hypothesis of the researcher, thinks that raw cornstarch diet will have a positive or negative effect on blood glucose levels. Okay, so either the blood glucose level is going to be greater than 100 or it's going to decrease. Okay, so we can say that alternate hypothesis is mu is not equal to 100, and we have been given that sample size is 30, which is given over here. Okay, so now we have to select the test statistic. So since the data of standard deviation of the population is provided to us, so we are going to use test statistic as z statistic. So x bar minus mu divided by sigma over root n is distributed as a standard normal distribution. So let us write down the given data into this equation. Here x bar is sample mean, that is given over here 105. Okay, so 105 minus it must be mu naught. Okay, and what is mu naught? Mu naught is 100. Okay, 105 minus 100 divided by standard deviation of population is 15, so we should write down 15 divided by root 30 is distributed as normal distribution. Okay, so this is our test statistics from the sample. So if we solve this, it would come out to be 1.83. Now let us calculate the p-value. So to calculate the p-value, we need to see the z distribution table. So now, as we have seen that our test statistic from the sample data is given as 1.83. Okay, and since it is two-tailed test, so we can write down by symmetry this is minus 1.83. Okay, so what is the p-value? P-value is the probability of extreme data, which in this case is area under this curve and area under this curve. So we need to calculate the area under right tail as well as left tail. Okay, so from the table for 1.83 we need to see this row. It is given over here that for 1.83 z is 0.96638. Okay, so and the table value represent area to the left of the z score. Okay, so area till this point, the cumulative area of the curve till this point is 0.96638. So what would be the area of this shaded curve? It would be 1 minus 0.96638. Okay, so if you solve this, it would come out to be 0.0336, and by symmetry this area would also be 0.0336. So what is p-value? P-value is 2 times 0.0336, which is 0.0672. So we have seen from the z distribution table that this is 0.0336 and this is also 0.0336. So p-value is twice 0.0336. Since it is the two-tailed test, it would come out to be 0.0672. Okay, so it is 0.0672, and we have been given in the question that alpha, which is 1 minus c, is 1 minus 0.95 is 0.05. It is clear that p-value is greater than alpha, and we have seen that if p-value is greater than alpha, then we would accept our null hypothesis. Okay, so we would accept our null hypothesis that blood glucose levels for obese patients have a mean of 100. Okay, so that's all for now. Thank you. Keep watching YG Data Science.